Hi class, it's Dr. Brody. Welcome to the first episode of the Intro Psych audio lectures. I hope you'll throw on some headphones and go for a walk while listening to these greatest hits episodes from each chapter. The audio recordings highlight key points from each chapter and are meant to complement, not replace, a careful reading of each chapter. I'd like to begin this unit with the story of Clever Hans. Clever Hans was a real horse from the early 1900s who became famous because people believed he could do math. Crowds would gather to watch him answer arithmetic questions by stomping his hoof the correct number of times. Naturally, people were skeptical. Either the horse could truly do math, or there was another explanation. Researchers began systematically testing different possibilities. They removed the owner from the situation, changed the people asking the questions, and varied the way the questions were presented. Yet Clever Hans continued to provide the correct answers. The mystery was eventually solved. Clever Hans was not actually doing math. Instead, he was extraordinarily skilled at reading subtle cues from the people around him. As he approached the correct answer, audience members would unconsciously change their facial expressions, breathing patterns, posture, or other micro behaviors. Hans learned to stop when he detected those cues. The lesson from Clever Hans is extremely important for psychology. Clever Hans effect demonstrates experimenter bias and observer bias. Researchers can unintentionally influence participants in ways they don't even realize. This chapter is all about research methods and how scientists work to avoid accidentally influencing the outcomes of studies. When psychologists conduct research, there are so many decisions they have to make. Research begins with a question, always. Researchers then choose a research design, they determine how variables will be operationalized, they select methods for collecting data, and they decide how results will be analyzed. This is where you can and should apply your knowledge from the textbook about what a theory is, a hypothesis, and what we mean by operational definitions. Once a study is completed, the findings must be shared publicly so that other researchers can evaluate and replicate the work. Replication is a critical part of science because it helps verify whether findings are reliable. Scientific knowledge is built through transparency and repeated testing. We want studies with high rigor. Critical thinking plays an important role here, avoiding sources of bias such as overconfidence and hindsight bias. This is really key for a researcher. The scientific community also relies on peer review. Before research is published in a scientific journal, experts evaluate the study's methods, analyses, and conclusions. This process helps distinguish high-quality science from poorly conducted research or unsupported claims. As you encounter scientific claims in news stories in everyday life, it's important to think critically. Ask questions about how the study was conducted, whether the methods were sound, and whether the conclusions are actually supported by the evidence. One of the most important lessons in this chapter is that correlation does not prove causation. Let me say it again. Correlation does not prove causation. A correlation simply means that two variables are related. As one variable changes, the other also changes in a predictable way. However, if two variables are correlated, we cannot automatically conclude that one causes a change in the other. It may be that variable A causes variable B. It may be that variable B causes a change in variable A. But it is also possible that a third variable, variable C, causes both A and B. A classic example here is the positive correlation between ice cream sales and murder rates. Yeah, it would be unreasonable to conclude that eating ice cream causes murder or that murder causes people to buy ice cream. That's where common sense kicks in. But in fact, we can't rule out those possibilities with just knowledge of a correlation. Instead, we might actually think critically and say, hey, I wonder if there's a third variable that's influencing a change in both. Maybe that third variable is hot weather. Higher temperatures can increase ice cream sales, while also being associated with increases in aggressive behavior and crime. So, when we say that correlation cannot prove causation, it could be that A causes B, it could be that B causes A, or it could be, like in this case, C causes both A and B. Because correlational studies cannot determine causation, psychologists rely on experiments when they want to investigate cause and effect relationships. Experiments are considered the gold standard when causation is the goal, when we want to assess that A does cause B. In an experiment, researchers systematically manipulate an independent variable and they observe its effect on a dependent variable. They use random assignment and careful control of conditions, and that allows them to isolate the factor that is responsible for producing a change in the outcome. Be sure you understand the differences among descriptive research, correlational research, and experimental research, as well as the terminology associated with each approach. Ask yourself why some methods might be chosen for particular areas of interest. For example, why might a researcher choose a case study? At the end of the chapter, you will also encounter some basic statistical concepts. Statistics are really important for the study of psychology. You should be familiar with what we mean when we say measures of central tendency. So, be able to calculate and understand what we mean by saying the mean, the median, and the mode. These concepts provide simple ways of describing data and serve as a foundation for future coursework in statistics and research methods. So, these are some of my greatest hits for Chapter 1. I hope you enjoyed the story of Clever Hans. It's a classic in Intro Psych. And as you now move forward through reading the book carefully, start thinking like a scientist. Ask questions, evaluate evidence carefully, and apply critical thinking to the information you encounter. All right, then, I'll see you in Chapter 2.